What if I told you that the idea of natural talent is mostly a myth? That you have the same latent potential as the world's top performers? We're taught that some people are just born with it, the genius gene, the magic touch. But what if that's a lie we've been telling ourselves? The truth is, there's a science to learning things fast, a repeatable formula backed by neuroscience that can turn the average person into a rapid learner. It's not magic, it's a manual for your brain. Stick around, because in the next few minutes, I'm going to give you that manual and show you how to unlock your own human superpower. You won't believe how simple the real secret is. All right, let's just get into it. We all know the stories. Mozart composing symphonies when he was basically a toddler, Tiger Woods hitting golf balls before he could walk. It's easy to look at them and think, wow, they were just built different. We call it talent, genius, a gift from the gods. And yeah, that makes for a great story, but it lets us off the hook, doesn't it? It gives us an excuse not to try. But what if the science tells a completely different story? See, for decades, scientists thought our brains were like hardware. You were born with a certain processor, a certain amount of RAM, and that was that. You couldn't really upgrade it. But that entire idea has been thrown out the window. We now know our brains are wildly adaptable, a concept called neuroplasticity. Think about the famous London taxi driver study. To get a license in London, you have to memorize the knowledge, a labyrinth of 25,000 streets and thousands of landmarks. It's an insane feat of memory. When scientists scanned the brains of these drivers, they found something incredible. Their hippocampus, the part of the brain responsible for spatial memory, was physically larger than the average person's. Their brains had literally rebuilt themselves to meet the demand. This is our first big aha moment. Your brain isn't hardware, it's software, and it's constantly being rewritten by everything you do. Skill isn't something you're born with, it's something you build. So that immediately begs the question, right? If skill is built, how do we build it faster and stronger than everyone else? Let's talk about a substance in your brain called myelin. You can think of it like the insulation around a copper wire. The more you practice a specific skill, whether it's a guitar chord, a tennis swing, or a math problem, the more your brain's glial cells wrap layers of this fatty myelin sheath around the relevant neural circuits. Each layer makes the signal faster and more precise. A bare neuron is like old-school dial-up internet, slow, laggy, unreliable. A heavily myelinated neuron is like a fiber optic cable, transmitting data at blinding speeds with perfect clarity. A little practice gives you one thin layer. A lot of practice gives you a super thick, high-speed cable. That's what skill is. It's a physical structure in your brain. A person with talent isn't magical. They just have a lot more myelin wrapped around that specific circuit. This changes everything. We've all heard the 10,000-hour rule, but that was a massive oversimplification. Just mindlessly repeating something for 10,000 hours doesn't guarantee expertise. The real game isn't about counting hours. The game is about myelination. How can we trigger that process most efficiently? So how do we trigger it on command? How do we hack this process to build skills at like superhuman speed? By the way, if this is already starting to click for you and you want to keep getting smarter about how you learn and operate, do me a huge favor and hit that subscribe button. This channel is all about digging into the science of peak performance and making it simple and actionable. Your support is literally what keeps this whole thing going. Thanks a bunch. Now, let's get back to hacking your brain. Okay, So we know our goal: trigger targeted myelin wrapping. Forget practicing 10,000 hours just for the sake of it. That's old news. We're talking about smart practice, not just hard practice. And this smart practice, this deep practice as some call it, really boils down to 3 key pillars. We're going to build from good to better to the absolute game changer. Pillar number 1, deconstruction. You don't learn a language by trying to memorize the entire dictionary. That's insane. Instead, you find the 20% of words and grammar rules that are used 80% of the time. This is the Pareto principle and action. Every complex skill is just a bundle of simpler, smaller skills. Want to learn guitar? Don't just stare at the whole instrument. Deconstruct it. The first chunk is learning the 8 or 10 basic chords that make up thousands of songs. The next chunk is a simple strumming pattern, then switching cleanly between those chords. You master each tiny piece, then you chain them together. This is the payoff. You get to bypass all the fluff and focus only on the components that deliver the biggest results. It's a massive shortcut. Chess masters don't study every possible move. They master the fundamental opening patterns and endgame principles. But just knowing the pieces isn't enough, is it? You can have all the Lego bricks in the world, but that doesn't mean you can build the Millennium Falcon. So how do you actually practice those pieces to make them stick? That brings us to pillar number 2, practice at the edge of your ability. This is the sweet spot. It's a state cognitive scientists call desirable difficulty. It's that zone where you're not bored because it's too easy, but you're not frustrated because it's too hard. You're reaching, you're making mistakes, you're failing, but you're succeeding just enough to stay motivated. It's like lifting weights. If the weight's too light, you get no muscle growth. If it's too heavy, you can't even lift it. You need the weight that makes you struggle on those last few reps. That struggle is the signal for growth. That feeling of struggle is the exact signal your brain needs to say, "Whoa, this is important. I better myelinate this circuit because we're messing it up." Here's the mind-blowing insight. Mistakes aren't a sign of failure. Mistakes are the instruction manual for growth. Every time you mess up a guitar chord and then correct it, you are literally triggering a biological process to wrap another layer of myelin. People who learn fast aren't afraid of looking stupid. They actively seek out these mistakes because they know that's where the growth happens. So now we're deconstructing skills and practicing at the edge of our comfort zone. This is already leagues ahead of how most people learn, but what if we could pour gasoline on the fire? This is the ultimate pillar, the one that ties it all together, the Feynman technique. Richard Feynman was a Nobel Prize-winning physicist, but his real genius was his ability to make incredibly complex ideas simple. His method is the key to deep, lasting learning. It forces you to move beyond shallow memorization to true comprehension. The process is simple. Learn something, then try to explain it in the simplest terms you can, as if to a child. Anywhere you get stuck, or use jargon, or say, "It just kind of works like this," bam, you've just found a gap in your own understanding. So you go back, relearn it, and simplify it until your explanation is smooth and clear. This process of reorganizing the information in your brain builds incredibly robust and interconnected knowledge. A fun practical tip here is called rubber ducking. Programmers do this all the time. When they have a bug in their code, they will literally explain the code line by line to a rubber duck on their desk. In the process of explaining, they find the flaw. It works for anything. And here it is, the big one. Learning isn't about getting information into your brain. It's about being able to pull it out. When you force yourself to retrieve information and explain it, you are building the strongest possible neural pathway. It's the difference between looking at a map once and actually having to navigate the city yourself. One is passive recognition, the other is active recall, and it's 100 times more powerful. This is incredible for mental skills, but is there a way to supercharge our brain's chemistry itself, to make it even more receptive to all this learning before we even begin? So we have this system: deconstruct, practice on the edge, and teach it to solidify it. But what if I told you the timing of when and how you learn can be just as important? We can actually manipulate our brain's chemistry to create the perfect state for learning. It starts with focus. When you are intensely focused and even a little bit agitated or stressed, think a deadline, a competition, or just intense concentration, your brain releases neurotransmitters like epinephrine, adrenaline, and acetylcholine. Epinephrine gives you energy and alertness, but acetylcholine is the real star here. You can think of it as a chemical spotlight. It sprays onto the specific neurons you're using at that moment and essentially marks them for change, making them more plastic and ready to build new connections. The hack? You can create this state on demand. Techniques like the Pomodoro method, where you work in intense 25-minute sprints, aren't just about time management. They generate the exact kind of focused attention that floods your brain with these learning chemicals. You are artificially creating the urgency that primes your brain for myelination. You can literally decide when your brain is in its peak learning state. But this raises a critical question. You do all this work, you focus intensely, you build these new circuits. How do you make sure your brain doesn't just, delete it all overnight? We've all crammed for a test and forgotten everything a week later. How do you stop that? The answer is the most underrated performance-enhancing tool on the planet: sleep. This is not a joke. The real magic, the actual cementing of your skills, happens when you're unconscious. During the deep, non-REM stages of sleep, your brain goes into hyperdrive. It replays the neural circuits you practiced earlier that day at 5x or 10x the speed, strengthening them and locking in facts and motor skills. Then during REM sleep, it connects those new memories to all your existing knowledge, fostering creativity and insight. This is why you sometimes wake up with the solution to a problem you're stuck on. Your brain was working on it all night. A good night's sleep after a session of intense practice is not time off. It is the most critical part of the learning session itself. If you're not sleeping, you're not learning efficiently. Period. So the superpower, the secret to accelerated learning, isn't one trick, it's a complete system, a learning machine you can build. Deconstruction is the blueprint for your machine. Edge of ability practice is the engine fueled by your mistakes. The Feynman technique is the quality control, ensuring every part is perfectly understood. Intense focus is the fuel, priming the engine with the right neurochemistry. And finally, sleep is the nightly maintenance and upgrade cycle that solidifies the build. That's it. That's the formula. It's not about being born a genius, it's about knowing how to operate the machinery you are already given. It's a skill, and like any other skill, it can be learned. So, now you have the manual. The question is, what are you going to build with it? What's the one skill you've always wanted to learn but thought you couldn't? Let me know down in the comments. I genuinely love to hear about it. If this video flipped a switch for you and gave you a new perspective, do me a favor and hit that like button. And make sure you're subscribed so you don't miss the next deep dive. Thanks for spending some time with me today. Now, go learn something amazing.